Hello folks, welcome to Edupedia World 9th Grade Computer Applications video lecture series. I'm Upeka Vandibona and this is the second part of Object Orientation Principle, Inheritance. If you can remember, when we were discussing about the basics of the inheritance concept from the previous episode, we said when one class inherits from another, that means that the subclass extends the superclass. Now, when you want to know if one thing should extend another, apply the is-a test. For example, let's take triangle and the shape class. Here, triangle is a shape. Yes, that works. Therefore, when we define the triangle class, we can mention triangle extends shape. Same goes with the surgeon and the doctor. Surgeon is a doctor. Therefore, at the class definition, we can say surgeon extends doctor. To find out whether you have designed your class inheritance relationships correctly, ask, does it make sense to say class X is a class Y? If it doesn't, there you know there is something wrong in the design. Now let's take the example bathroom class and the tub class. Is it correct to say tub extends bathroom or else tub is a bathroom? Definitely it is not correct. Now what if we reverse it to bathroom extends tub? That still doesn't work. Bathroom is a tub doesn't work. Tub and bathroom are related but not through the inheritance relationship. Tub and bathroom are joined by a has a relationship. It is more sense to say bathroom has a tub rather than bathroom is a tub. That means bathroom has a tub instance variable. In other words, bathroom has a reference to a tub, but bathroom does not extend tub and vice versa. This illustration shows you how the has-a relationships should be designed. In here, it got three classes, bathroom, tub, and the bubbles. Now, bathroom has a tub. That means in the bathroom class, it got a tub instance variable. And tub has a bubbles. That means tub class has a bubbles instance variable. But nobody inherits from anybody else. Hope you got a clear understanding of the difference between has-a relationship and the is-a relationship. In the inheritance, we are using is-a relationship, not the has-a relationship. Therefore, in this episode, we are talking about the is-a relationship. When you find out any relationship among two classes, always try to identify whether it is a has-a relationship or a is-a relationship. If it is a is-a relationship, that means you are using the inheritance concept. Now this is-a test works anywhere in the inheritance tree. If your inheritance tree is well designed, with the is-a test, it should make sense when you ask any subclass if it is any of its superclasses. If class B extends class A, class B is a class A. This is true anywhere in the inheritance tree. If class C extends the class B, class C passes the is-a test for both B and A. Let me show you this with an example. In here we got three classes, animal, canine and wolf. And canine extends animal, wolf extends canine, therefore wolf extends animal. In other words, canine is an animal, wolf is a canine, therefore wolf is an animal. With an inheritance tree like the one shown in here, you are always allowed to say wolf extends animal or wolf is an animal. It makes no difference if animal is the superclass of the superclass of wolf. In fact, as long as the animal is somewhere in the inheritance hierarchy above the wolf, wolf is an animal will always be true. This structure of the animal inheritance tree says to the world, wolf is a canine, so wolf can do anything a canine can do, and wolf is an animal, so wolf can do anything an animal can do. But there might be a few things that wolf and canine might perform what they do in a different way. And that is called overriding methods. Now keep in mind that the inheritance is a relationship works in only one direction. For example, triangle is a shape makes sense, so you can have triangle extend shape, but the reverse, shape is a triangle, does not make sense. So the shape should not extend triangle. Now always remember that the is a relationship implies that if x is a y, then x can do anything a y can do. And sometimes it may be in a different way. And sometimes x may be doing more than what y can do. Now here is a frequently asked question by people who getting to know the inheritance concept. What if the superclass want to use the subclass version of the method? Now this superclass, it won't necessarily know about any of its subclasses. You might write a class and much later someone else comes along and extend it. But even if the superclass creator does know about the subclass version of a method, there is no sort of a thing like reverse or backward inheritance. Now think this as children inherit from parents, not the other way around. Now here is another frequent question. In a subclass, what if we want to use both the superclass version and overriding subclass version of a method? In other words, if I don't want to completely replace the superclass version, can I just add more stuff to it? Yes, you can do this. You can design your superclass methods in such a way that they contain method implementation that will work for any subclass, even though the subclass may still need to append more code. In your subclass overriding method, you can call the superclass version using the keyword super. It's like saying, first go run the superclass version, then come back and finish with my own code. Here you are given an example of an overriding method in a subclass, the roam method. By using the super.roam statement, we call the inherited version of the roam method and then come back to do the own subclass specific code. Previously we said in the inheritance concept, a subclass inherits members of the superclass. Members in the sense, the instance variables and the methods. Now the superclass can choose whether or not it wants a subclass to inherit a particular member by the level of the access the particular member is given. Access levels control who sees what, and they are crucial to have a well-designed, robust Java code. We already know two access levels, public and the private. In Java there are actually 4 access levels: private, default, protected and public. But up to now it is just enough to know the private and the public access level. The rules are simple for those two. Public members are inherited, but private members are not inherited. So actually it is not good to say a subclass inherits all the members of the superclass, because it is depending on the access modifier the members are having. Now when you incorporate inheritance concept into your design, do not try to abusively use it. These simple guidelines provided in here will be helpful to you to build up a better inheritance design. We have listed out do's and don'ts when using the inheritance. Let's start with the do's. Use inheritance when one class is more specific type of a superclass. For example, willow is a more specific type of a tree, so willow extends tree makes sense. The second one. Consider inheritance when you have behavior that should be shared among multiple classes of the same general type. For example, square, circle and triangle all need to calculate the area and calculate the perimeter. So putting that functionality in a superclass shape might make sense. And that would make maintainability and the extensibility much easier. Now let's go with the don'ts. Do not use inheritance just because that you can reuse code from another class. For example, imagine you wrote special printing code in the alarm class and now you need printing code in the piano class. So you have a piano extend alarm so that piano inherits the printing code. And that makes no sense. A piano is not a more specific type of alarm. The correct way to do that is have the printing code in the printer class, so that all the printable objects can take advantage where has a relationship. The second one. Do not use inheritance if the subclass and superclass do not pass the ESA test. Always ask yourself if the subclass is a more specific type of the superclass. For example, Tea is a beverage makes sense, but beverage is a tea doesn't make sense. Now let's talk about the benefits that inheritance brought you in. You can get rid of duplicate code by abstracting out the behavior common to a group of classes and sticking that code in a superclass. That way, when you need to modify it, you have only one place to update. And that change reflected in all the classes that inherit the modified behavior. In here, you only need to compile the modified class and do not need to touch the other classes. And the other benefit is inheritance lets you guarantee that all the classes grouped under a certain supertype have all the methods that the supertype has. In other words, you define a common protocol for a set of classes related through inheritance. When you define methods in a superclass that can be inherited by subclasses, you are announcing a kind of a protocol to other code that says, all my subclasses can do these things with these methods and look like this. In other words, you are establishing a contract. Let's take our previous example, animal class. The class animal establishes a common protocol for all the animal subtypes. And you are telling the world that animal can do these 4 things: make noise, eat, sleep, and roam. And remember, when we say any animal, we mean animal and any class that extends from animal, which again means any class that has animal somewhere above it in the inheritance hierarchy. So finally, with all of these benefits, we will be able to write a code that is flexible, much cleaner, more efficient, and simpler. If I add more into that, we can say it is much easier to extend what you have originally written. And that's all about inheritance. From the next lecture, we are talking about another object orientation principle, polymorphism. So thank you for watching and see you in the next episode. This video brought to you by edupediaworld.com. Watch more from our website.